Welcome everyone to this live stream. A little bit of update and code review. Are we even live? Actually, I should probably have checked the audio as usual. Anyway, I noticed not only, well, usually some people unsubscribe. Again, if you unsubscribe, maybe leave in the comments why, that I can do better. And second of all, also maybe some Patreon people already unsubscribed. And someone said even the next time they get the paycheck, they want to donate something. I even commented there, please not if you live from paycheck to paycheck, then maybe do not donate there to Patreon or something. But the thing is, of course, the YouTube experiment here, developing open source and stuff, financed with YouTube AdSense, of course, not working the most amazing, maybe a little bit of a failed experiment here. So a small message by your former president.
I know a lot of people want to send blankets or water. Just send your cash.
Yeah, just a little bit funny video snippets there. But yeah, the problem is this, as you see, I do not over dramatize here the issue of coding here, but this reverse engineering stuff, of course, takes plenty of time. Trial and error, especially if you don't have specification like on the bloody NVIDIA stuff. This is why, yeah, don't send your cash if you live from paycheck to paycheck, but otherwise it would be really cool. Otherwise, maybe I would then turn to more commercial work here that better pays or at all. Yeah, link is down. So, yeah, there you have it, TG3. We tested this also. Why do we have 0 drop frames? So this is hilarious. Yeah, so the switch, then we tested this also only here live on YouTube. So I only wonder why did this catch up with drop frames? That is funny. Yeah, so only live on YouTube. The TG3 issue, I have it already. So the Linksys switch is at least not responsible for this annoying TG3 issue, although we somehow online again. This is really, link is down, link is up. Yeah, anyway, so this is a real TG3 bug, can't make this up. We solved this also. Looks is catched up somehow or something. Anyway, yeah, so for failing hardware, send your money or something of that sort. Anyway, so I wanted to do a little bit of code review because we certainly want to get this ps3 frame buffer stuff more amazing, and you can also learn something. So even if you are not in ps3, so what did this fail again here? Or no, we are thermal throttling. Of course, we are Mac Mini. Anyway, amazing stuff. So a little bit of code review, and you can also learn something if you're not in ps3. Also how much hardware is buggy and NVIDIA sucks. So here's our GitHub code and some notes. So I mentioned in why is sometimes stuff also for all those like the guy who runs OS News there, Tom Holveta or something. You probably can check this right. Because I caught him here once, Tom Holveta. He is usually often writing their software sucks and something. Yeah, I don't like this very much because honestly, well, yes, software often sucks. I'm myself calling out peak bugs on macOS, but hardware also often really sucks. And this is what I want to call out here, and I want specification. Maybe this is also why NVIDIA is not giving us a specification, because this NVIDIA silicon just has too many bugs. Because if you look here, this is a Novo code here, and this code is pretty similar. You see here exa copy in the official original Novo code, and this is our P3. Most likely the original developers maybe even copied it from there. Looks pretty similar. Here DMA start, and so if you want to get into RSX programming, that is where you can inspire from. And they also have here something strange, like maybe they have worked around your similar graphic corruption artifact that we are. Here's some clutch, split the destination rectangle in an upper misaligned half and a lower tile aligned half. Then get image blit to blit, like block transfer. The lower piece downwards request for sync to vblank. If the area to be blitted is large enough, the blob does a different, not nicer trick to achieve the same effect. So blob, of course, meaning binary only NVIDIA driver. So maybe the problem is I can't copy this directly. Also, actually, now that I remember, I wanted to show something else out. I can't even in this version of Firefox right now. My tabs crash. Anyway, because the other thing is, some people ask, yeah, but there is an NVIDIA driver. Yeah, also not this. Should have opened this. And to compare this with the original NVIDIA driver, here somewhere in -NV, 0 frames, amazing stuff. -NV is here. So the original NVIDIA driver, open source. I said this also in previous streams when people said, yeah, but there was an NVIDIA driver, yes, but this is full with magic numbers. The Novo developers call this obfuscated. Also not as amazing code. Also maybe no EXA here, there is no EXA for that. But even if you look here into EXA for G80, then you will see that this is full, all the other also, this is full with magic numbers. Exactly how you should not do it. Also, do we have more failing? Oh yes, internet, so something. This was H, of course I wanted XRC. And yeah, so you see here, this is full of magic numbers. This, of course, well, it gives you a little bit clue how this works. Of course, not the most amazing. Welcome in the audience, by the way, Devi and everyone. So this is what people with Novo and other open source developer call out as obfuscated and full of magic numbers. So yeah, it gives you something. So this most likely is here some format stuff, but this is of course not nicely done. This is not how you should write drivers with magic numbers all over the place. Yes, my own DOS stuff also has some magic numbers that we should get rid of. But this is a difference of nicely coded and full of magic numbers. Yeah, again, so the Novo, where did I leave the ps3? I had this there somewhere. I opened here the wrong stuff, it looks. Anyway, so did I really use the wrong tab now? Apparently. Yeah, here it is. So yeah, this is maybe a workaround for that, but I will most likely not focus. The problem is I can't copy this directly because this is using here also some push relocation, something, whatever. I also don't quite see where here is a different. Oh no, we're not. Yeah, so we have this also. So again, latest kernel, this TG3 instability stuff here is still. Wait a second, this should be, this is not, are we not back online? Comments in the audience, are we back online, or this is also hilarious that, maybe because you can stream back online, no, we maybe online, what a hiccup. So yeah, so again, we had this earlier in this live stream, this is when you stream with hardware, of course, chiming in here in the different, not even NVIDIA, but also Broadcom TG3 crap, really ridiculous. Again, what I said in the beginning of this live stream, not only not fixed with the very latest Linux kernel here, 5.2.9 on this failing Mac Mini, but also not the switch, so it's not the crappy switch fault for the TG3 thing here. It's this nice new Netgear, the same thing. I really wonder. And yeah, this is of course 2019, right? Basically everything you look at is a little bit broken there, a little bit broken there. And NVIDIA full of workarounds and glitches and bugs. And this is why I call this out and want to shout this out and spread awareness of like bugs and not only blaming software like Tom Werder or something. Blaming the software, no, it's often not only the software and stuff, it's also, yeah, if you have to work with hardware bugs and don't even have the specification. So the main point of this video, I also wanted to do some code review of the frame buffer and how not to write a frame buffer driver. Although I have to say the original developers here at Sony Corporation, the problem is of course they didn't have hardware or did not want to politically allow hardware acceleration, and this is why they had to implement it so crappy. Why? What do I mean with this? Yesterday I said that I want this 9 megabyte back, especially for you playing along at home with your retail PS3 that only has 256 megabyte minus a little bit of virtualization hypervisor overhead. And people said, yeah, but the VRAM is also 256. Yes, and yesterday I explained already that the Linux kernel frame buffer, because this reading this memory is back, and the problem is other programs, even the frame buffer for scrolling, the Linux console for scrolling, is reading the memory back. And this is why they allocate system memory so that the CPU local memory is fast for read and writing for even the frame buffer scrolling here for the text. And this is why I want this memory back, because the PS3 is already memory limited, and not only my developer tool, I can of course have 9 megabyte back, more so for you at home. And where do they do this? Or why? If you look on the Wikipedia, is this what is this official Wikipedia? Interesting. Really? Did I open here? Okay. Anyway, so you see here this is also maybe even on. This is really seriously Wikipedia. Are you completely kidding me? It's interesting that this memory addresses are. Yeah. So maybe if can't even believe that here that this. I thought I'm on the P3 dev wiki. And yeah, so here you have this documented, meaning the latencies and bandwidth. Really funny that, so this is also for those who want to play along at home, the frame buffer, and then the RAM instance memory hash table, FIFO contexts, DMA objects, graphic objects, and graphic context. Yeah, and so this is what we are working with. And this is what I'm talking about. So the cell to the RAM bus XDR memory is 25 gigabit per second, pretty fast. Just a pity that it's so little. And cell to RSX is also relatively fast. So this is cell, the PowerPC core writing into the RSX memory, the graphic DRAM memory, a little bit slower, not too bad though, 15.8 gigabit per second, gigabit or gigabyte actually, whatever. And then the cell from the RSX that is like reading textures or stuff, also still relatively fast. However, the RSX2 and wait a second, where are we here even? This is confusing. Anyway, let's look on this table. The point is here that the cell reading cell right what? Yeah, the cell reading from the somehow this is somehow only local, right? Anyway, whatever. So the cell reading from the frame buffer, and again you need this for all blitting, transparency in fact, and stupidly enough the frame buffer of the Linux kernel, it's really stupid. This is also why in general all over, even on the Octane, the scrolling is so slow. I wish they would just have the text in memory, that of course the text and attribute very little data, but whatever, because the reading back, so the cell reading memory from the RSX local video memory, only 16 megabyte per second, or maybe even slightly less. Maybe this was measured overclocked or something. Then here 550 versus 650 megahertz. And yeah, 16 megabyte, of course, totally slow. And this is why you have yesterday seen when I disabled the graphic acceleration for One Direction, why this then was so totally laggy. And this is why, to work around this, so the Sony developers could have allowed the Linux frame buffer to just directly write, but writing is fast, or okay-ish fast, but reading is super slow, so scrolling would be totally laggy affair. Scrolling in the sorts of like 2 frames a second. Of course, nobody wants a frame buffer scrolling with just 2 bit BLTs, frames per second, totally hilarious. Slow piece of garbage. And so to work around this, because again, the political decision from Sony not to have graphic acceleration. So for this they have here DDR and XDR. And so XDR. And the situation is slightly worse. Then actually funny that they compare. So this is upstream, right? This is not our modifier, this is upstream in Linux kernel vanilla today. And so what they basically do here is, and I always knew this, I knew this a decade ago, and already, and I was already, because a decade ago I had a retail, my fat PS3 was only 256 megabyte, totally not amused. And here you have DDR frame buffer size. So DDR is the RSX local video memory, and XDR is the cell local rhombus memory. So they allocate this here like twice. Here's the sizes, so just a variable of the sizes, and then they allocate this here somewhere, XDR LPAR. So this is a physical address. I wonder, however, if we can, I only hope we can really get away with this. So what I ideally would want to do, where do they even allocate this? Or I hope the hypervisor doesn't allocate this for us. XDR base, frame buffer size, XDR. I hope the hypervisor even allows us to do this. So there you see, where's all the time going? You thought you have already researched this. Somehow the XDR base, why is this? Anyway, the situation, I review this in a moment later, and there you see maybe live stream not the best format if this is so unsorted. But the situation is even worse. So the problem is all the programs like games, frame buffer console, and the unisolated original like frame buffer X server, they write into this cell local memory, the fast rhombus memory, the fast and precious small memory, and then the kernel driver, he needs to copy this to the RSX DDR memory to scan it out on the HDMI output. And I was wondering how they do this. I've never looked this up because it was never a thing. So only today I looked this up. So if you wonder what do I do here with your Patreon donations, this is what we're doing here. So only today I realized they have here a daemon. This is kernel thread. This is this ps3fbd here. And this is, you see here, they created a kernel thread thread run with this function ps3fbd info device name, this task here. And if they can't create the kernel thread, then if error, then they unregister the frame buffer and error out here. Of course, it should be registered and running. So the situation is even worse than I thought, because I was aware that this wastes, if you don't change the kernel configuration, 9 megabyte of memory. It's hilarious. And on top of this, because I was looking how do they track the modifications. So normally I thought they copy this bitBLT with the RSX, asking the hypervisor nicely to do this. And no, they don't do this, not on like dirty write modifications. They always do this, so they waste total amount of memory bandwidth. I actually wonder if our P3 becomes slightly faster if we disable this. So not only do I want my 9 megabyte memory back, but because this is constantly running this kernel thread, so what they do here is, so they set here, so this is a kernel thread that is, while this should not be stopped, like infinite loop here, while loop, until this is requested. So probably until you unload the frame buffer, and this is like set like K thread should stop. Then they try to freeze, set current state task interruptible, and then if this P3 frame buffer is kicked, so only if this is like, this is some variable, local variable here of this driver, if like is kicked out, in general I also not like the names and most professional names, but whatever. Can also name it dirty or to zinc or whatever. Anyway, is kicked, then they reset this variable, is kicked equals 0. They assign this here to 0, clear it, basically lock the console, and then call this zinc p3fb zinc, then unlock. What is this function doing? This is using the previously asking the hypervisor LV1 GPU display to what, this is not P3fb zinc. Where is this even? Here, yeah, so zinc image and num frames and ps3fb sync image here, and this most likely hopefully calls the hypervisor, I would guess here. So LV1 GPU frame buffer blit. This is the only thing that Sony allowed back in the day to do. And what is even worse, so I still wondered, like, how do they sit this is dirty, like how do they track, you could theoretically do this, right? For example, if you have something compiling, the series works that we're doing, you have a static image of your desktop, nothing is animated and moving there. And so you would think then no blitting is done, but oops, boy, the wrong is kicked here. So where do they set this? They set this is kicked, they assign this like is dirty is kicked variable in the vsync interrupt. So vsync, of course, vertical resync here of the ps3 frame buffer vsync interrupt. So like 60 times a second, whenever this vsync interrupt kicks in here, they by the context interrupt, what is this even doing? Context handle LV on interrupt failed, what? Anyway, so if this is a vsync interrupt, then they increment the vblink count here, just if someone cared, and then set here this is kicked variable. So basically, I think, as far as I see here right now, this kernel thread is constantly 60 times a second or plus minus, unless it is like something is slower, then it's maybe only 50 times a second. So this also wastes enormous amounts of bandwidth, right? All the bandwidth, the RSX with raster bitblt copying here the XDR rambus memory into the frame buffer, of course totally unnecessary, especially if not much stuff changed. So yeah, the only problem is I just realized, so I already was aware, where do you wonder where's all the time going? Not only does it take here probably an afternoon or a day to delete all the code, you would think, yes, this is easy, just delete here all the stuff, the creation of the kernel thread and this functions. Of course, deleting is always easy. However, it is a little bit more because, of course, a little bit code needs to be shuffled around. Also, instead of XDR base or something. So because ideally, of course, this will be super slow. So if we remove this and we wire up this code so that it exposes the pointer to the P3, to the RSX local DDR memory, it will be super slow. As for example, even the console scrolling will be slow because it can only read back the frame buffer with 6 megabyte per second. And so we definitely need to wire up the hardware isolated bitblt there for the scrolling, otherwise it will be too slow. And yeah, wonder slightly, so many things to do. So this, what would be the benefits? The benefit is we do not lose 9 megabyte of memory, precious memory, especially for you at home, and certainly lots of bandwidth here, 60 times a second. How much bandwidth is this? Quite a lot. If we calculate this, this is for a full HD. This is 1920 by 1080, right, by maybe 4 bytes. So this is divided by 1024. So this is 7, apparently 7 megabyte per frame, I guess. Is this, if I didn't miscalculate? They also wonder why 9 megabyte. Yeah, because full HD frame, so something maybe does it even support 200? Yeah, they are 9 megabytes, so one frame buffer 9 megabyte, if I didn't miscalculate, so something 1920. Yeah, probably. And this 60 times per second, so these are 527 megabyte per second of bandwidth wasted for nothing, just copying, scanning out the frame buffer. Hilarious. It's really a pity that, yeah, anyway, it's really historically sad. I wonder, though, XDR base, where, so frame size, where do they reset this? Pen offset, DDR base. I would have thought they allocate this, so memory allocate. So this is frame buffer alloc in, oh, this is only the alloc cmap, dalloc cmap alloc context handle, where would that be? IO remap. Let me quickly check the kconfig here. By the way, comments in the audience, does it here load or does it not load? Yeah, so here is default frame buffer size in megabytes, so this is 9 megabyte. You could or increase or decrease this, or can be overwritten with ps3 frame buffer equals something. Let's see where that would actually, maybe the allocation is early. Maybe this is in early kernel for even being able to allocate so much memory actually, because it's not easy to allocate so much memory in the monolithic Linux kernel. Yeah, comments in the audience. Otherwise, thanks for watching. Don't forget this amazing YouTube video I showed earlier already. Because so much time, very small, can't repeat.
I know a lot of people want to send blankets or water. Just send your cash.
Yeah, really sorry to call this out, also didn't read here. So because I really want to spend so much more time, but given that the YouTube channel is not the most popular because of all the failing videos and stuff, it's a little bit hard to justify all the time spent here for making this more amazing. And pre-allocate bootman memory, here is something, config, pre-allocate. So yeah, this is in setup C, just as why is this here? Because as I said, in monolithic kernels or in general, it is not so easy to allocate so much, what is the term, like not like so much continuous memory. This is why they do this early, because if later in the kernel this memory is fragmented all over the place, allocating, deallocating and stuff, this is why everything becomes totally fragmented, and this is why they pre-allocate this here. Okay, so this, I only wonder, yeah, so this is why they need to do this very early in the setup stuff, because only then they can guarantee with especially as little memory here, to be able to allocate 9 megabyte of continuous memory. And yeah, so this could be removed then, if that even works. So video size, where would be the pointer to? By the way, I hope you learned something, also if you're not interested in ps3. And actually I can check, I was actually emerging some stuff here, Python, that you can't see now because I don't have, this is, what did I say needs to be rebuilt? This mb underscore lang max was this glibc, then can't compile here. Yeah, cross compile hiccup or something. Anyway, so here's the p address that would be in, alright, this is probably here in this address, ps3 pre-alloc. ps3 video memory extern. So let's see where this is used. I hope we can. Yeah, and I really wonder if compilation becomes some 5% faster with all the bandwidth actually wasted. That would be extremely cool. But actually, we can probably test this already, because the difference would be whether you have this running in the frame buffer or with our modified ps3fb. That should already stop the daemon. I only wonder if we actually, this is the next thing, I actually wonder if maybe this is our sporadic, because I actually wonder if we really cancel the ps3fb threading thing there. It could actually interfere with our frame buffer. with our driver. So yeah, so here's this PS3 video memory addressing. So there is somewhere should be, so address memset, so clear this memory address, and then it is, okay, so this is, here it is doing that. So this is PS3 memory management physical to LPAR. So LPAR address, this logical partition addressing, and so it is, so here's size, Alex, so, but it is, so because the problem is it looks a little bit, does it XDR LPAR, maybe we cannot totally get away with this if it's already supplying this to the hypervisor. GPU IO IF. So maybe somehow they unfortunately designed it so that somehow you need to, why would they do this? There's really some GPU frame buffer start, so maybe you can, maybe we only need some small portion of the memory, because here's some offset that I just scrolled over. And because here's GPU frame buffer start, would this be some 65K offset, and in the beginning is a IOIF region map? Yeah, so this is 64, so in the beginning is this IOIF thing, so then I wonder if we can get away with only source offset. Yeah, so there's our 64K offset for that region. And then the question is, yeah, but even that will be a couple of reboots until this works. I'm slightly more comments. Anyway, yeah, thanks for watching. Somehow not the most comments. Also, yeah, why I somehow, this is not the most amazing video content, probably to live stream all of this trial and error reading here, trying to understand the code here. FB Blitz, yeah, so this also explains why we have this offset in the X server. I actually was wondering if this is official or not, so then here it's really official. GPU IO context IO map, video memory size. Yeah, but somehow this is then really annoying that we need to find how we can work around this. Anyway, yeah, thanks for watching. So much details, so much stuff to do. Hope you learned something anyway, and I hope to see you soon for all the next video and content stuff to come.